Welcome dear friends. I am Ganaraj Kutpallivar. Welcome you all in our channel named as Last Minute Passing. Our aim is to create a failure-free engineering society. With that, I come with a video of unit number 5 of refrigeration and air conditioning subject. It is a totally theoretical subject, and on the in the basis of this unit, there will be the question of 16 marks for 8 marks and for 8 marks. Okay. So there were some topics which are not covered in our local books, but you have to prepare for your exam. So on this basis of that, there were some topics I've taken. First is summer air conditioning system. As the name suggests that in the summer there is a requirement of cooling. Okay, because atmosphere is very hot and very humid. Okay, so on the basis of that there is requirement of cooling and there is requirement of dehumidifier to remove the water content in that uh, air conditioning system. Okay. So this is a systematic arrangement. So in the question they ask that please explain the summer air conditioning system and draw the layout and draw the advantage and disadvantage. Okay. So you have to draw this diagram and say that from the damper the air is come. First filter is used to remove the contaminants in the air, remove dirt, and some bacteria which are harmful to us. And in the cooling coil is used to remove the or cool the air. Okay. uh, One is it's dehumidifier. What is the role of this dehumidifier? It is a perforated membrane. Okay, it is a perforated membrane having dew point temperature is less than the dew point temperature of incoming air. So what is the use of that dew point temperature? The dew point temperature is used to remove the water contents or to remove the uh, humidity in that air or in this pattern. Okay, so the dew point temperature of this coil is less as compared to the incoming air. Okay, so here the air is come across this coil and it get dehumidified, and some heating coil is there which is used to maintain the required temperature as per the situation or as per the requirement. Okay, fan is used to circulate that air in the conditioned space, and this air is circulated. Next topic is winter air conditioning system. So in the winter there is requirement of heating. So heater is employed. The basic difference between summer air conditioning system and winter is that in the summer there was a heating coil. Here, there was a cooling coil. Here there is a heating coil, which is used to heat that air. So in the winter there is humidity is less and the requirement of humidity is more. So to increase the humidity in that air there is humidifier. Okay, there is a reheating coil also to maintain the required temperature, and the according to the space requirement it adjusts the temperature of this air. The fan is used to recirculate that air. Okay, and next one is year round air conditioning system. As name suggests that if we use the summer air conditioning system in at the next place and winter at the next place, there is a if we use both separately then it increases the size and cost is more. If these both the things will become in one unit, then it's very beneficial for us. So year round air conditioning system is employed for that. So air is come from the outside, damper is used to control that air, filter is remove the contaminants in that air. Okay, and the cooling coil which is used in summer, it's activated in a summer. Okay, in the summer there is requirement of only cooling and dehumidifying. So cooling coil is used to uh, rem- remove the heat. Okay, in the summer, and necessity of dehumidification is fulfilled by maintaining the temperature of that cooling coil lower than which temperature? The dew point temperature of that cooling coil must be lower than the dew point temperature of incoming air. By this way, we have to achieve the effect of air at the summer. So in the winter, what we do? The cooling coil get off, heating coil is on, humidifier is on. Okay, so by this way, we have to heat that coil and humidify that coil. Why the humidifier? In the previous one, we are using the water to humidify it, and in that, what do we do to humidify? Some agents, humidifying agents, silica gel, and all this humidifying agent we have to use to humidify the air. and remaining work is same as the above. Unitary air conditioning system. So one topic is unitary air conditioning system. There is no necessity to draw these all the unitary layout of this unitary air conditioning system. Just understand the concept behind that. Unitary air conditioning system as we see our window air conditioning. What in our home there is one at the window, and at that window we have to place one air conditioning. As we see the old air conditioning system, in that it break the windows, and in that window we have to place that air conditioning. That's called unitary. At one place we are employing that air conditioning, and it circulate there from that one place. Okay, it is a unitary air conditioning system. Okay, we move towards our central air conditioning system. In that central air conditioning system, we have to put our unit at centrally at that one place. Okay, and we through ducts we circulate that air towards the required place. So this is centrally we have to done one arrangement, and through ducts we have to circulate that air through various outlets, but at a very section, but the preparation unit at one place. That is the central air conditioning system. Okay, see all air system. What is the all air system? And in the all air system we are using the air for a cooling purpose. Okay, see the brief scenario or brief image of that all air system. See the air, this is the here on this side, here one arrangement of evaporator. Okay, this is a VCR cycle. Okay, so the air here come, it get cooled in the evaporator, this in this box. Okay, and this cooled air gets supplied through the blue ducts. Okay, in the air in the room. Okay, here for cooling medium we have to use the air. That's why this system is called all air system. Okay, at never we haven't used the liquid for the cooling. Okay, that's called all air system, or air conditioning system also all air system. We move forwards for all water system. This is our all water system. That all water system use the water for cooling. Previously we said that at evaporator box there is a air is come and air is get out, but in the all water system the water is come in that evaporator box and gets out and cooled and circulate through various rooms where we want to require the cooling. Okay, it gets circulate to the various rooms. Okay, and warm water get out from the outlet, the warm water get out and again come to that box. Okay, the air gets circulated to the over the coil of that water. Okay, it's increase the heat transfer in that process. Next is typical all water system. This is all water system we have to use. Now if we see the all air all water system, this is also one system in this topic. Here all water system, only the water tubes are there. In all air and all water system, this combined system we have to use. Okay, from the first box only water is passes. Okay, in the all air and all water system we have to split that water, and we split that evaporator box. From the first box water is passes and second box air is passes, and distribute the system. Hermetically sealed compressor. This is a hermetically sealed compressor. Okay, the use of this hermetically sealed compressor is to compress the air, compress the refrigerant in the refrigeration system. Okay, so how the compressor is work? From the suction we see from this side, from the right side, the suction port, low temperature low pressure vapor refrigerant, it's come from that, and it gets sucked inside the cylinder through the piston and cylinder arrangement, and it gets compressed at a high pressure and high temperature. It is a working of that. Screw compressor, in the screw compressor there are two screws, and in the space between these screws, from the inlet the refrigerant get comes inside that, and in the space between that screws is some space or pocket, we have to say that refrigerant is get trapped and get pressurized. Okay, just like this. Inlet is there and outlet is there. Scroll compressor. Scroll compressor. What is the use of scroll compressor? Here is one stationary disc and one rotating disc. From the inlet, sorry, from the outside, the refrigerant gets comes inside that scroll compressor. The fixed disc was fixed, and the rotating disc is rotated in a clockwise direction. And the due to rotation of that rotation disc, the space of the refrigerant is get varied. And due to varying the space of the refrigerant get compressed and the pressure is increased. Just like that. Okay. Then condenser. Condenser, there are two types. Air cooled condenser is when the condenser is used to change the phases of the refrigerant. To change the vapor of phase to liquid refrigerant. Okay. So air is get come across the condenser, and due to the transfer between the refrigerant and air, the air sucked the heat from the refrigerant and heat transfer get occurred, and the phase change of the refrigerant takes place by air only. Okay. Water cooled condenser, the water is used to cool the air. Okay, the heat transferring media, the here in the condenser there is a requirement of rejection of heat from that refrigerant. So whom the refrigerant get transferred that heat, so refrigerant transfer it heat to the some media. In the air cooled it transfer it heat to the air, and in the water cooled condenser it transfer it heats to the water. That's why it's called water tube condenser. In that water tube condenser, this is the first type, that is a tube and tube type condenser. In the tube and tube type condenser, from the one tube air is passes and another tube water is get passes. Okay, sorry, and another tube water is passes. Due to the contact between, but indirect contact between the water and the refrigerant, there is heat transfer takes place. So which type of heat get transferred in this heat transfer process? In this heat transfer process, there is a latent heat is get transferred. Okay. Next we move towards our shell and coil type condenser. In the shell and coil type condenser, there is one shell from which the refrigerant get passes, and one coil from which the water which cools the refrigerant get passes, and the remaining work is same as that. Shell and tube type condenser. In the shell and tube type condenser, this is one shell and tubes. Okay. From the tubes get water get passes, and from that shell there is a refrigerant get passes. It transfer get occurred, and refrigerant moves out. Then evaporative condenser. In the evaporative condenser, the refrigerant vapor enters in the coil, and refrigerant get out from that coil.